Hi, I'm Dr. Uma Sharma. I've been teaching chemistry online for past 20 years. In this video, we'll practice making of Lewis dot symbols of neutral atoms in their ground state and excited state of the electronic configurations. We'll practice Lewis dot symbols of some elements. We'll discuss nitrogen, sodium, and iodine. First step is to write on the symbol of these atoms. If you don't know how to write on the symbols, you can take help of the periodic table. Nitrogen symbol is N, sodium is Na, and iodine is I. Next step is to count the valence electrons. In this, we can take help of the periodic table. Nitrogen is with 5 valence electrons. Sodium is with 1 valence electrons. It is in the first group. Iodine is in the 7th group, so 7 valence electrons. So the valence electrons can be determined with the help of periodic table. Nitrogen, 5 valence electrons. Sodium, 1 valence electron, and iodine, 7 valence electrons. Place these valence electrons as dots around the symbol of the atoms. So first we are going to write down the symbol of the nitrogen. We are going to place 2 electrons of the s orbital which are present as a pair in the electronic configuration, and the remaining 3 electrons as 3 single electrons. Sodium, you are going to place 1 electron only. Iodine, again you are going to place 2 electrons of the s orbital as a pair. Then we are left with 5 electrons which are present in the p orbitals of the electronic configuration. So first you are going to place 3 electrons out of 5. Now 2 are still left. Then pairing starts. So this is how you are going to fill the electrons around the symbol of the atom in the Lewis dot representations. Now let us practice some more examples. We are going to discuss xenon, sulfur, and magnesium. So very first step is you are going to write down the symbols of these elements. Symbol of xenon is Xc, sulfur is S, and magnesium is Mg. The next step is to count the valence electrons of these elements. In this we can take help of the periodic table. In the periodic table you can see xenon is in the 8th group, so its valence electrons are 8. Magnesium is in group number 2, so its valence electrons are 2. And sulfur is in group number 6, so its valence electrons are 6. So the valence electrons of xenon are 8, magnesium 2, and sulfur 6. Now we are going to place dots equal to the number of electrons around the symbol of the element. First, let's do for xenon with 8 electrons. We are going to place first as a pair which is present in the s orbital. Then you are going to place 1 single electron on the 3 sides of the xenon symbol. And then to place the remaining electrons, we have to pair them. In case of magnesium, there is a pair of electrons in the s orbital. So these electrons will appear as a pair only. In case of sulfur, we are going to place a pair of electrons first, and then we are going to place 1 single electron around 3 sides of the sulfur. Now you can see that we have placed in total 5 electrons. So 1 is left. So that electron will pair up with one of the electron of the p orbital. There is an exception of helium in which the group number is not equal to the valence electrons. Group number of helium is A. It is a noble case, but its valence electrons are only 2. Because in its electronic configuration, the outermost shell is 1s and it has only 2 electrons in that 1s shell. So when you are making the Lewis dot symbol of helium, we have a pair of dot indicating these two electrons. They are present together as a pair because these two electrons are present as a pair. Let's practice some Lewis dot symbols of atoms in their excited states of electronic configuration. For example, carbon, its atomic number is 6. It has 6 electrons in its electronic configuration. Electronic configuration has 2 electrons in the 2s orbital and 2 electrons in the p orbital in the outermost shell. So the total valence electrons in the outermost electronic configuration of carbon are 4. The ground state, these electrons are present as a pair in the s orbital, and these 2 electrons are present as 2 unpaired electrons in 3 of the p orbitals. So this is 2s orbital and this is 2p orbital, px, py, pc. When carbon gets ready for chemical bonds, at that time, one of the electron jumps from 2s orbital to 2p orbital, vacant 2p orbital, and this is called as the excited state of carbon, where you can see only one electron in the 2s and 3 unpaired electrons in the 2p orbital. So the ground state Lewis dot symbol of carbon is with a pair of electrons as it is present in 2s and 2 single electrons as they are present in 2 of the 2p orbitals. However, in the excited state of carbon, when it's getting ready for chemical bonds, carbon has 4 unpaired electrons around it. And that proves the tetravalency of carbon, that it can make 4 chemical bonds by sharing 4 of its electrons. In case of boron, the atomic number is 5. Its electronic configuration is helium, that's the inner core, 2s2, 2p1. So there are 3 electrons in the outermost shell of the boron. 2 are paired and 1 is unpaired. So the ground state has 2 electrons present as a pair in the s orbital and 1 electron is present as unpaired electron in one of the p orbital. So its ground state Lewis dot symbol is the pair of electron and 1 single electron around the symbol. In the excited state, one of the electron jumps from 2s to one of the vacant 2p orbital, and now 2s orbital has 1 single electron, and in the 2p orbitals you have 2 single electrons. So when you make the Lewis dot symbol of the excited state of carbon, you can see there are 3 single electrons around the symbol as 3 dots. Beryllium with symbol Be, its atomic number is 4, so it has 4 electrons in its electronic configuration. Outermost shell is 2. It has 2 electrons in the s orbital, so the valence electrons are only 2. In the ground state electronic configuration, these 2 electrons are present as a pair in 2s shell. 2p orbitals are completely vacant. In the excited state, one of the electron will jump from 2s to 2p, and the excited state of beryllium has 2 unpaired electrons. So ground state of the beryllium is with a pair of electron in the Lewis dot symbol, and the excited state has 2 unpaired electrons. Similarly, aluminium, its atomic number is 13. It has 3 electrons in its outermost shell. 2 electrons are present in the s orbital in the ground state as a pair, and 1 electron is present in one of the p orbital, unpaired. In the excited state, one of the electron will jump from 2s orbital to 2p orbital, and now in the excited state there are 3 unpaired electrons. So the ground state Lewis dot symbol of aluminum is Al with a pair of electron and 1 single electron. Whereas in the excited state, the symbol is with 3 unpaired electrons. In this tutorial, we had practiced making of the Lewis dot symbols of neutral atoms in their ground state and excited state of the electronic configurations. In the next tutorial, we are going to learn how to make Lewis dot symbols of ions. If this video has been helpful to you, please click on subscribe and like icon below the video and share it with others on Facebook and Twitter. If you want to learn chemistry online from me or for more chemistry resources, visit my website www.chemtopper.com.